Hello viewers, welcome to the another session of postgraduate certificate in climate change. In the previous session we have studied and then discussed at length and the main concepts of the natural drivers of climate change. In today's session we will discuss about some of the important factors of the anthropogenic drivers of the climate change. So the atmospheric composition, first we have to understand that. So for that, the present day atmosphere we all know and then experiencing is quite different from the natural atmosphere, and also that existed before the industrial revolution, especially in terms of chemical composition. If the natural atmosphere is considered to be clean, then that clean air cannot be found anywhere in today's atmosphere. So there are many chemical anthropogenic emissions like chlorofluorocarbons, which they are considered once safe because they are inert in the lower part of the atmosphere, that is a troposphere. But once these chemicals enters into the stratosphere, that is the upper atmosphere, the ultraviolet radiation that can convert them into highly reactive species that can have a devastating effect on the stratospheric ozone. Similarly, anthropogenic carbon dioxide emissions from combustion process, that is incomplete combustion of fossil fuels, they were once considered safe because they are not toxic in nature as such. But the long-term accumulation of carbon dioxide in the atmosphere that may lead to a climate change which could then be harmful to human beings as well as the ecosystem. So the new Intergovernmental Panel for the Climate Change report that reflects the major advances in the science of attribution, that is understanding the role of climate change in intensifying specific weather and also the climate events like extreme heat waves and heavy rainfall events. So the report also mentioned clearly that human actions still have the potential to determine the future course of climate. So the evidence is the carbon dioxide emission, which is the main driver of the climate change, even as other greenhouse gases and air pollutants also affect the climate. So the stabilizing the climate that will require strong, rapid and also sustained reductions in greenhouse gas emissions, that is the anthropogenic emissions, and reaching the net zero carbon dioxide emissions. So limiting other greenhouse gases and air pollutants, especially methane, that could have benefits both for health as well as the climate. So for the anthropogenic drivers, first we will look into the changes in the land use. How these land use changes will directly link to the climate change. It is very strange and then surprising factor. So climate can affect and be affected by changes in land cover, that is especially the physical features that cover the land like trees or pavements, etc. And also the land use like human management and activities on land, and also the mining or the recreation, so on and so forth. So a forest, for instance, would likely include tree cover, but could also include areas of recent trees removals, that is currently covered by open grass areas. So land cover and the use which are inherently coupled with each other. So changes in land use practices that can change the land cover, and also the land cover which enables specific land uses. So understanding how land cover and then use, condition and the management that vary in space in time, which is a challenging, because the land cover and the condition that can be estimated using the remote sensing techniques. Land use and also management typically require more local information like field inventories, and identifying the identification of these field inventories, and then quantifying and comparing estimates of land use and land cover, which are further complicated by factors like consistency and the correct application of terminology and the definition, time scale, data sources, and also some methods. So changes in the land cover that can normally cause in response to both humans as well as the climate drivers. For example, the demand for new settlements often leads to the permanent loss of natural and working lands that can also result in localized changes in weather patterns, temperatures, and precipitation. So the aggregated over large areas, these changes have the potential to influence either climate by altering regional and global circulation patterns. So changing the albedo, that is here the albedo is reflectivity of the Earth's surface, and changing the amount of the carbon dioxide, that is a quantity in the atmosphere. So the climate change that can also influence land cover, resulting in a loss of forest cover from climate related increases in disturbances, the expansion of woody vegetation into the grasslands, and also the loss of the coastal wetlands and also the beaches because of the increased inundation and the coastal erosion, which is amplified by the rises in the sea levels. So now we have to understand the changes in the aerosol levels. So what exactly the source and the composition of the aerosol? So the atmospheric aerosols you must have studied in the previous sessions. They are suspensions of the liquid, solid or mixed particles with highly variable chemical composition as well as the size distribution. So their variability is because of the number of sources and also varying formation mechanisms, so and the chemical composition. So these aerosol particles, they are either emitted directly to the atmosphere, that is the primary aerosols, normally we can call them as, or they can produced in the atmosphere from the precursor gases. They are normally termed as the secondary aerosols. So the primary aerosols that consist of both inorganic as well as the organic components in nature. If we will see that inorganic primary aerosols, they are relatively larger in size, that is more than, that is 1 micrometer. We can call it as a mu m, and that can originated from the sea spray and the mineral dust as well as the volcanic eruptions. So these coarse aerosols, they have short atmospheric lifetime, that is a duration that is spending in the atmosphere, that is typically it is only few days. And then combustion process, or whether it is a direct combustion process or incomplete combustion of the fossil fuels or the biomass burning and the plant or the microbial materials, which are the sources of the carbonaceous aerosols, that they must be having the both organic carbon and the solid black carbon. So normally we can call it as an OC as well as BC. So black carbon is the main anthropogenic light absorbing constituent which is present in the aerosols. So its main source is the combustion of the fossil fuels, whether it is a gasoline, whether it is an oil, or it may be coal, wood or other biomass. So the primary black carbon are the OC that containing aerosols, which are generally smaller than the 1 mu m, that is a micro diameter. So secondary aerosols, if you will consider, these are the particles which are produced in the atmosphere from the precursor gases by the condensation of vapors on pre-existing particles, or we can also call them as a nucleation of the new particles. So a considerable fraction of the mass of secondary aerosols which is formed through the cloud processing. This is also one other technology for this one. So the secondary aerosol formation and then their diameter is also very less. So the ranges, it starts from the size from a few nanometers up to 1 mu m, and also have the lifetime of days to weeks. That means comparative to the primary aerosols, it is the lifetime is, it is a longer duration. So the secondary aerosols that consists of the mixture of compounds, the main components maybe it is sulfate, that is a chemical composition, nitrate, as well as the organic carbon. So the main precursor gases here, it is emitted from the fossil fuel combustion, and but fires as well as the biogenic emissions of the volatile organic compounds are also most significant in nature. So occasionally we can see that volcanic eruptions that also leads to the huge amounts of the primary and secondary aerosols both at the ground as well as in the stratosphere. So now the size and the chemical composition of the particles, if we will consider, they will evolve with that time through coagulation process or the condensation process, and also some types of chemical reactions. So the particles, they may grow by the uptake of water, and also the process which depends upon the chemical composition, particle size, and also the ambient relative humidity. So the different particles that have varying impacts in the atmosphere, that depends on the composition and the sources and the range in size distribution, and also they will further complicate a quantification of their effects. So both particle growth and the mixing of different particle types, that influence the climate effect of the aerosols. So now we have to understand that how these aerosols distributed globally. So here it is also one of the concept is there, that is the aerosol optical depth, that is retrieved by the remote sensing from the space, which is highly inhomogeneous in nature. So with the largest values in Asia and also the tropical regions of Africa, if we will consider. So the estimated contributions from the different aerosols types, that is selected in regions, and also they have done a lot of research by showing the pie charts. And also in general, if we will consider, a large spatial and also temporal variability in global aerosol composition we will see. We will observe this remote sensing from both space as well as the ground together with in situ. These observations have substantially advanced and also an understanding of geographical aerosol distribution, but there are still large uncertainties in the chemical composition and also the other anthropogenic contribution. So all these atmospheric aerosols, they may scatter the incoming solar radiation, and also a few aerosol types, they can absorb some of the solar radiation. So black carbon is the most important of this one, and the mineral dust and also some organic carbon, which are the components of, are also important for the sunlight absorbers. So the aerosols which are mainly scatter the solar radiation, that is having a cooling effect by the enhancing the total reflected solar radiation from the earth. So the strongly absorbing aerosols that have the warming effect in the atmosphere, and also there is a mixture of scattering and also absorbing aerosols in the composition if we will observe. So the net effect of the earth's energy budget, which is dependent on the surface as well as the cloud characteristics. So the scattering and the aerosols above a dark surface and absorbing aerosols which is above a bright surface, which are most efficient in nature. So scattering, that is coming from the absorption, and also aerosols which are about a bright, that is a darker surfaces, which are less efficient because the solar radiation is reflected anyway. So absorbing aerosols which are particularly efficient when positioned above the clouds, if we will observe, they are main contributor to the total reflection of the solar radiation back to the space. So aerosols, they are vital for cloud formation because the subset of them may serve as cloud condensation nuclei, that is normally we can abbreviate it as CCN, and ice nuclei, that is IN. So an increased amount of the aerosols by increase the CCN number concentration, and also the lead to more but the comparatively smaller the cloud droplets for fixed liquid water content. So that means this increases the albedo of the cloud, that resulting in enhanced deflection and a cooling effect, both in termed as the cloud albedo effect. So smaller drops that requires longer growth times to reach sizes at which they easily fall as the precipitation. So normally we can call it as a rain. So this effect is known as the cloud lifetime effect that definitely will enhance the cloud cover. So the life cycles of the clouds, which are controlled by an intimate interplay between the meteorology as well as the aerosol and cloud microphysics, that includes complex feedback processes. So absorption of aerosols that have the potential to modify the cloud properties without directly acting as CCN as well as the IN, like heating the air surrounding them while reducing the amount of solar radiation that reaching the ground, which stabilizes the atmosphere and also reduces the convection and the potential for the cloud formation. If you will see the second important criteria, that increasing the atmospheric temperature, that reduces the relative humidity and also inhibits clouds formation and enhances the evaporation of the existing clouds. So this is collectively termed as the semi-direct aerosol effect. So the net effect is uncertain and also highly depends upon the vertical profile of the black carbon. In addition, black carbon and other absorbing aerosols, they have deposited on snow or ice surface. They may reduce the surface albedo, leading to the reduced reflectance of solar radiation and hence a heating effect. So now we came to the most important aspect of our session, that is the radiative forcing. So far we have understood with all these effects what would be the radiative forcing. So when energy from the sun that reaches the earth, the planet absorbs some of this energy, that means a part of that energy, and also radiates the rest back to the space in the form of heat. So the earth's surface temperature depends upon the balance between the incoming as well as the outgoing energy. So the average conditions, they tend to remain stable unless the earth experiences a force that shifts the energy balance. So this shift in the energy balance that causes the earth's average temperature to become either warmer or cooler. That leads to a variety of other changes in the lower atmosphere, on land as well as in the oceans. So a variety of physical and chemical changes that can affect the global energy climate. So some of these changes are natural and some other are influenced by the humans. So these changes are measured by the amount of warming or the cooling effect they can produce, normally called as radiative forcing. So changes that have warming effect are called the positive forcing, and the changes that have the cooling effect are known as the negative forcing. So when these both positive and negative forces which are out of balance, then the result is a change in the earth's average surface temperature. So this is a very easy concept of radiative forcing. So now the greenhouse gases come into the picture. So what these greenhouse gases will do, they will absorb energy which radiates upward from the earth's surface and re-emitting heat to the lower atmosphere and also warming the earth's surface. So human activities which have led to increased concentrations of the greenhouse gases that can remain in the atmosphere that decades, centuries, maybe more than that. So the corresponding warming effect will last for longer time. So radiative forcing, now we can define easily that it is a change in the earth's radiation balance because of the perturbation of the anthropogenic or the natural origin. So the principal elements, if you will consider for the radiative forcing concept, are, the first one is, the concept was developed first in the context of the one-dimensional radiative convective model that is investigated the equilibrated global annual mean surface temperature, which is responses to the radiative perturbations caused by the changes in the concentrations of the radiatively active species. If you will consider the second criteria, that is the one-dimensional radiative connective model framework, the surface as well as the troposphere, which are closely coupled, that behaves as a single thermodynamic system under the joint control of radiative and then convective process, which is specified lapse rate determining the thermal structure. Now if we will see the third criteria, that is a stratosphere is a fast response system which in response to an imposed radiative perturbation that comes into equilibrium on a time scale. So that is much more rapid if we will see that the surface tropospheric system. And then fourth point is when a perturbation is applied, like increase in well mixed greenhouse gases, there is an instantaneous change in the irradiance that is manifest in general as a radiative imbalance, that normally we can call it as a forcing at the surface, that is the tropopause and the top of that atmosphere. So, and the fifth point, if we will consider for this one as a direct consequence of this above the forcing definition, what we have seen, that most appropriate for the response of the surface troposphere system to a radioactive perturbation in the net radiative change, which is defined at the tropopause after the stratosphere, that has come to a new thermal equilibrium state. And also we can also consider that a major motivation for the radiative forcing concept is the ease of climate change analysis, when radiative forcing, feedback as well as the climate responses which are distinguished from the one and another. If we will see that the critical aspect of the separability, which is mentioned as forcing, is holding the surface and the troposphere state, which is fixed in the evaluation. So radiative forcing of the climate change of the radiative forcing, we can consider that the foregoing governing factors that reflects the fundamental recognition that in response to an externally imposed radiative forcing, which is a shift in the equilibrium state of the climate system. So with all these factors, I would like to conclude that the climate drivers that can also trigger feedbacks that intensify or weaken the original forcing. For example, forcing from the increased greenhouse gases that are also increases evaporation, that increases water vapor in the atmosphere and intensifies the forcing from the greenhouse gases. If we will stabilize the anthropogenic climate drivers that are currently increasing the radiative forcing of the atmosphere, Earth's energy balance and climate will eventually reach a new state of the equilibrium, and also where the equal amounts of energy which are transferred into and then out of the system, when this will occur remains as an open question. So with these, I would like to conclude. Learners, you must be benefited with this session. In the next session, we will discuss about the climate feedbacks. Thank you.